Let's talk about magnetic resonance imaging, MRI for short. According to the Mayo Clinic, these long donut-type scanners are often used to help diagnose brain aneurysms, multiple sclerosis, strokes, blood vessel blockages, bone infection, and cancers. MRI scanners use a magnetic field and radio waves to create a 3D image using a map of the water within our bodies, which there's a lot of since we are about 65% water. To put into perspective how strong a magnetic field MRI scanners create, their magnetic fields are 1.5 to 3 Teslas on average, whereas our Earth has a magnetic field of 6 to the power of -5 Teslas. The hydrogen atoms from the water in our bodies are detected by the Mri technology. They are made up of a proton and an electron. The proton acts as a magnet, and the atom is constantly spinning at a random axis facing up or down. When the scanner's static magnetic field B0 interacts with the hydrogen atoms, they align themselves with B0. Then a frequency is produced that resonates with the spinning motion, called the resonant precessional frequency of the protons, which causes them to face away from B0. To focus on a part of the body, a stronger magnetic field, B1, is introduced there. The new magnetic field makes the protons rotate faster. Then the resonant precessional frequency of the protons in that region is produced. In order to turn the spinning protons into images, the new precessional frequency is turned off, which causes the protons in the targeted area to flip back into alignment with B0. The energy released by the flip is then detected as a current by coils, which are able to produce very precise images of the targeted region. The information from an MRI scan is used to inform medical professionals about the chemical makeup and structure of the targeted body part. Before MRI scanning technology, illnesses in the brain took many lives before they could be diagnosed in the patient's postmortems. MRI technology has been shown to be extremely effective in diagnosing and preventing illnesses, while also helping scientists see the results of experiments in real time through the scans. This is particularly useful for neurologists who are trying their best to increase the shared understanding of the human brain through experiments in studying volunteers' MRI scans. Another benefit of MRI scanning technology is that it produces no radiation, like X-rays or CT scans, making it safer to use repeatedly without harmful side effects. There are, however, a few downsides to MRI technology to consider. The first being that there are multiple artificial magnetic fields created. Having any metal jewelry or implants on is a risk, as they can become projectile objects. The second downside is that the frequencies have been known to cause second-degree burns in rare cases. The final downside to MRI technology is that a common contrast agent used to help create better images, called gadolinium, may prove toxic to our waterways and rivers. Gadolinium, made unreactive using a chelation agent, is consumed by the patient before a scan and expelled through the urine within the next 24 hours. It cannot be filtered in our waterway treatment facilities and has been shown to become reactive again when exposed to UV rays. Let's talk about some careers that use this technology. First up is an MRI Technologist. MRI Technologists take the images that MRI scanners produce using the coil sensors of energy change due to the realignment with the original magnetic field. These images are studied by radiologists. Radiologists are doctors who use the information collected from various scans and study the images and numerical data passed to them by the MRI technologists and condense it so that they can communicate the information easily to the other doctors and their patients. Let's discuss the contribution of two scientists to MRI technology. The first is Sir Peter Mansfield. Nobel Prize for Physiology or Medicine winner Sir Peter Mansfield is known as the founding father of MRI technology. His first contribution to the creation of MRI technology was his attempt at creating solid-state nuclear magnetic resonance technology, NMR for short, that could be used to study the bonds and arrangements of crystalline solids. It was discovered that his method of NMR technology could be applied to the study of the human body, being much more precise and safe than radiation imaging. The only issue was that it was extremely slow when it was first introduced, so Sir Mansfield devoted his life to improving the speed as well as other aspects of MRI technology. Dr. Ravi Menon is a Canadian scientist who has degrees in physics, medicine, and medical physics. Much of Dr. Menon and his colleagues' work has been to help develop the hardware of the MRI scanners in terms of the resonant frequency coils and methods to keep the rodent still in preclinical trials. They have also worked on making RF coils for neuroimaging that work with 7 Tesla MRI machines. Thank you for watching this video. I hope you have learned something new about MRIs today.